Hi, hello, welcome to Meki Techie. Learn as engineer, teach as champion. First of all, I would like to thank my family for their continuous support and encouragement for creating these kinds of technical videos in public domain. And I would like to thank my mentor, Professor R. Surendran from Government College of Technology, Coimbatore, igniting me a spark of creating these kinds of technical videos in public domain. I would like to thank Almighty for my good health and broad mind, and my friends, followers, my dear students, and subscribers for their continuous support and encouragement. Today's topic of interest is heat treatment. So, heat treatment is a process in which the material property can be transformed. In the heat treatment, even the soft material can be made as a harder, or a hard material can be made as a softer by means of heating the material above and below the recrystallization temperature, and underwent some process and cooling process in such a manner that the desired property can be drawn. So we have six to seven processes, different types of processes in heat treatment that we are going to discuss in detail here. First, first we are going to introduce annealing. The process is called annealing. The annealing means the material is heated above the recrystallization temperature and cool it by means of furnace itself. So we put a material in a furnace and heat up to recrystallization temperature. The recrystallization temperature is the temperature at which the grains, the newly produced grains, new grains can be produced. So that is called as a recrystallization temperature. So we heat up to recrystallization temperature and the new grains will be formed, and the new grains are let it cooled in the furnace itself. What it means that it will have a very slow cooling process. In the very slow cooling process, we get coarse pearlite structure. This coarse pearlites improves the three things called SMS. S means softening, missionability, and stress relieving. So, this is the main process of annealing. In annealing, we can have four different types of an annealing process. One is process annealing. In the process annealing, the internal stresses are being relieved. The same process is done, whereas the internal stress, for relieving internal stress, will give an importance. Therefore, it is called as a process annealing. And next one, full annealing. It is the process of making a softening or improving ductility in a material, that is called as an full annealing. Spheroidizing is the process of improving machinability. Therefore, if we done this annealing process, get we can improve softening, machinability, and stress relieving on our materials. Next one is a diffusion annealing. Here, the diffusion of atoms is happen. Next one is the normalizing process. Normalizing process is very similar to annealing process, that is, we are heating the material above the upper critical temperature, that is called above recrystallization temperature, and cool it in air. The difference here is cool it via air. Therefore, we know that the furnace cooling is bit slower, whereas air cooling is bit faster. Therefore, here the fine pearlites are formed. This fine pearlites will improve the mechanical property and it refines the grain size. Therefore, here we get fast cooling than annealing process. Therefore, if you have to remember by the name, we have a normalizing where make R is a bigger, and here what R means refined grain structure. So that is our understanding. Next is a hardening process. Hardening process, it is very similar to the annealing and normaling process. We are going to heat our material up to or above recrystallization temperature, that is upper critical temperature, and we are going to quench with some other mediums. We are going to quench with some other mediums like brine solution, oil, water, mineral oil, vegetable oil, cooling water, warm water. Like that, we are going to change the cooling medium. Once again, remember you, in annealing, the cooling medium is furnace. In normalizing, the cooling medium is air. Whereas in the hardening process, the cooling medium is liquids like water, oil, brine solution, mineral oil, vegetable oil, cooling water, warm water, like that. Here, what is the difference is the sudden cooling is happen when the sun, if you think this, in the recrystallization temperature or upper critical temperature, the new grains are formed. Those new grains are suddenly quenched. We are not tend the new grains to elaborate and to combine. Therefore, sudden cooling is happen here. When the sudden cooling, the material get becomes huge harder or bit high harder, like martensitic structure is happen. For the martensitic structure, it will give a 65 HRC Rockwell hardness number. This is our understanding about the hardening. The sudden quenching is happen. Therefore, here I would like to add some other points. That is, the brine solution will give highest hardness than other quenching medium, and NaOH, that is salt. Salt give harder than water. Salt is give harder than water. Water gives harder than oil, and oil is a less harder. It will produce less harder the rest of the things. Martensitic structure is the needle-like structure. When we zoom it in a metallographic microscope after hardening process, the structure will be like a needle structure. That is, it is like a very hard structure. The properties, the outcome properties of the hardening process is the material becomes more brittle, less toughness and less ductility. So therefore it is high harder, but it will easily get breaked. It is not at all useful. Therefore the post hardening process is going to be done. The post hardening process is nothing but the tempering and Austempering. So these are all the post hardening process. That is, in first of all, the tempering. After hardening, the slow heating and slow cooling, the continuous slow heating and slow cooling to be done for converting the martensitic structure into tempered martensitic. So this process, slow heating and slow cooling after hardening, will reduce the brittleness and increase the toughness and increase the ductility. So this is our interest. So we don't need that much amount of the hardness, but we are in need of producing toughness as well as the ductility. So after hardening, the tempering process is to be done. This tempering process is slow heating and slow cooling process. Next is the Austempering. The Austempering is the process of after heat treatment, after hardening process, the material is again heated above upper critical temperature, and we are going to done an isothermal quenching. The isothermal quenching is the slow process. The isothermal process is basically a slow process. Therefore, here there is no cracking as well as less distortion is happen. Therefore, the Oz tempering process 100% bayanite structure will be getting. The bayanite will have the 100% bayanite will have more toughness. Therefore, austenitic above 723 degrees Celsius will be converted. And after that, the more tempering is a process. We can, it is also a after tempering process we can use more tempering and Oz tempering. we are going to heat the material above upper critical temperature and will be came by means of an oil or an air cooling to the room temperature. Here, the austenitic structure is converted into martensitic structure. Therefore, the maximum hardness and brittleness will be having. In the Mar tempering, the outcome structure is martensitic. Therefore, this Mar tempering is also called as a stepped quenching or the interpretant quenching or Mar quenching, we can say. So with this, the heat treatment, the whole body heat treatment have been done. The next, we are going to discuss about surface treatment. In the surface treatment, we have two types of surface treatment. One is full surface treatment. In full surface treatment, we are not using the quenching process, whereas in selective treatment, we are using the quenching process. Quenching means sudden cooling. Okay. In quenching, we have to produce heat. Therefore, the flame hardening and induction hardening is the process where the selective treatment is having. This flame hardening is oftenly used in machine tool guideways like lathe guideways are using flame hardening process, and the induction hardening process basically used in engine crankshafts. So here this selective heat treatment, we have a quenching process, whereas in the full treatment we are subdividing into carburizing, nitriding and cyaniding and carbonitriding. These processes will not at all need quenching process. So here we are going to discuss those processes. So here the different types of processes is in our left, and the source constituents, that is hardness and applications, have been uh, detailedly tabled. First of all, carburizing. Carburizing process, the material is heated at 800 degrees Celsius, and this carburizing we can done in three forms, both solid, liquid and gas. In solid state we use coal. Generalized coal is used for the solid carburizing, and for the liquid carburizing HC solution is used. For gas carburizing, ethane HC gas is used. C2H6 is the formula. By using this any of these process, we can improve carbides. Therefore, no quenching. Carbon atoms are diffused in the surface. The carbon atoms are diffused in the surface. Where in the carburizing process, high depth of surface treatment is happen, the carbon is introduced in the surface layers. Therefore, a surface of carbon is being deposited in the carburizing process. Where in the nitriding process, we are using ammonia gas Na3CO3 plus nascent oxygen. This, the material will be heated up to 490 to 590 degrees Celsius, and it is dipped into the ammonia and a nascent oxygen solution, and nitrates are formed. This nitrogen is diffused in the surface of the material. Therefore, high fatigue strength, high wear resistance, and high surface hardness can be achieved. This nitriding is done in salt bath as well as plasma and gas nitriding processes. Next one is the cyaniding process. We are using cyanide solution, and the material is heated up to 490 to 590 degrees Celsius, and it is dipped in cyanide solution. In the cyanide solution, the ammonia gas is being used. Ammonia and sodium cyanide is being used. Therefore, uh, we get carbon plus nitrogen atoms are diffused in the surface. Therefore, it will produce very high hardness of the steel. Very high hardness of the steel. This hardness can be withstand up to 870 to 954 degrees Celsius. So that is the advantage of cyaniding. Next is the carbonitriding. Carbonitriding, is a liquid source is being used, no quenching process. And here also carbon and nitrogen components are diffused in the metal. Therefore, high wear resistance will be given. Therefore, it produce a maximum HRC at 55 to 62 HRC, and the material is being heated up to 650 to 920 degrees Celsius. After heating the material in 650 to 920 degrees Celsius, we are put the metal into the liquid source. Therefore, the carbon and nitrogen atoms can be diffused in the surface. Next is the selective hardness. In the selective hardness, the flame hardening and induction hardening coming to picture. In the flame hardening, generally the oxyacetylene gas flame or an oxyhydrogen gas flame is being used, and this flame is put in the oxidizing flame. This flame is make as an oxidizing flame. We know that in oxyacetylene gas treatment process, we can produce three flames: oxidizing flame, carburizing flame, and neutral flame. We are using oxidizing flame for producing high temperature. Here, the heating process are in contact. The heating process are in contact. This oxidizing flame is directly touches the material which we are going to make hard, and this is a process of heating and quenching, the continuous heating and quenching. Therefore, the surface heat treatment, the selective surface is being treated or being hardened. This type of uh, process is applied in machine tool guideways as well as the lathe guideways. Next one is the induction hardening. Here, the heating is done by a coil. Here, the coil is in non-contact in nature. We know that in our iron box and microwave oven, non-contact heating is produced by means of an induction, that is, microwaves are passed through the material. Therefore, by means of the microwave, high velocity of microwave touches the atoms and it will produce heat. Therefore, non-contact type of a heating is being done, and here also heating and quenching is going to be done. The quenching medium is water or oil or a polymer based quenching can be used. This type of a process, induction hardening process, is applied in automobile crankshafts so that uniform hardness can be achieved at the selected surfaces. Here, the heat, how much heat we are going to produce, that can be controlled by an equation of I square RT, where I is the current, R is the resistance, and T is the time. This H is the heat, that is Q. I hope that I have given an enough knowledge on the heat treatment process. Uh, if you have any doubts, please let me know in the comment section. I'll make another video for clarifying your doubts. With this, thank you all.